The daylight project. Background information. The spinning of the Earth like a top is called rotation. It takes 24 hours to rotate once. This is how we define one day. Notice that the knob on the Earth model has 24 tick marks. Here's the knob that turns the little model Earth, and it has 24 little tick marks going around the edge there. Let's see if we can get this into focus. There we go, now it's in focus. 24 tick marks going around. Each tick mark helps you see how far Earth will rotate in 1 hour. To see how far Earth rotates in 8 hours, you just turn the knob so that 8 tick marks pass the arrow. We have a little arrow right there, so 8 tick marks would be how far the Earth rotates here in 8 hours. Goal. We will look at how the amount of daylight changes during the year and how that affects the seasons. Number 1, the divider around each Earth model separates the day side of Earth from the night side. So here we have the dividers I was talking about. This represents the sun, and so as I match this up here, this side here, that's on the sun side, that's going to be hidden by the sunlight, that's going to be day. Over here, the sun can't shine on this side of Earth, and so that's the night side there. Because that's the night side, we're going to cover that up with a box to help represent darkness and nighttime. Number 2, since the Earth's axis is tilted, each area of Earth gets a different amount of daylight. How much is the Earth tilted? And this is a pretty good estimate as to how to draw it. So is that 2 degrees, 20 degrees, or 80 degrees, that little swoopy section there? I'll let you decide what that is. Next, a complete orbit around the sun is called a revolution. 1 revolution takes 1 year. During this entire time, the tilt of Earth stays pointed in the same direction. We will look at 1 year in Chicago. Find the red pin on the Earth model. And as I turn this around and around, there I can see the red pin right there. Have the Earth model at the spring equinox position. Have the spring equinox label on the Earth. Touch the spring equinox label on the sticks. I have that basically set up as it is right now. Place the 4-sided box over the part of the Earth that does not get sunlight. Again, the back side of the Earth away from the sun here. This is the night side, so it's covered up by the box. Find Chicago on the globe and spin the model around once. During 1 whole rotation, how many hours will Chicago have on the sunny side? So right now is right at the red dot there is right at the boundary between the night side and the day side. So that's the morning dawn moment. And now let's count the number of tick marks that go by here as we rotate this around till it hits this position. When it's going into the darkness, that would be the sunset. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And now that red dot is going back into the nighttime. So 12 hours. And number 4, during the whole rotation, how many hours will it be on the night side? So I keep on turning. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And now the red dot's coming out into the day side. So it's 12 hours in the night, which kind of makes sense. 12 hours a day, 12 hours at night makes 24 hours in the full day. Next page. Do the following questions in your lab group. Move the Earth model to the summer position. Okay, so now I'm going to move it over to here in this position, and I'm going to move the nighttime box to be on the back side away from the sun. Okay, we're going to spin the model around once again, and Chicago's on the sunny side for how much? So let's rotate it. There we can see the red dot coming out from the night side, right there. Let's count the number of tick marks now on the daylight side. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14. Now it's entering the night side, and it was 14 tick marks, 14 hours to go from this position on one side to this on the other. 14 instead of 12 hours. Now on the night side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it was 10 hours on the night side, 14 hours on the day side. Okay, now move the Earth model to the fall equinox. It's going to be right here. And we're going to move the night side to this side right here. And get Chicago on the border. And now let's count how many hours, how many tick marks it is on the day side, on the sunny side close to the sun here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 12 hours on the sunny side, so therefore it's going to be 12 hours on the night side. 12 plus 12 is 24. So that's 7 and 8. They're both 12 hours. Okay, next we're going to move it to the winter position. Okay, and we start counting. This is the winter position. 1, 2, 3, 4, 5, 6, 7, 8. 8 hours on the sunny side. So now let's count on the dark side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And now it's coming out. So 14 hours on the dark side, on the night side. So number 10 on the the night side is going to be 14. Number 11, the big idea of this activity is that Chicago is warm during the summer because it gets, I'll let you figure that one out. Okay, now we're going to look at Greenland. Okay, here we have a little blue dot way up there. There's the red dot, there's the blue dot. We're going to be looking at this one. Number 12, put the Earth model in the summer solstice. There's a summer solstice there. Line this up appropriately. The night box. Number 12, put the Earth model in the summer solstice position. Match up the two labels as before. Here, each day, northern Greenland gets how many hours? Okay, so let's look at this again. Where is Greenland? There it is, that little dot right there. And we can see that it never reaches the dark side. Now it's pointed over here. It never goes on this back side of the cardboard divider. It is always on the sunny side of Earth. And so that's why Greenland and the other parts of the extreme north have 24-hour days of sunlight during the summer. Number 12 then, 24 hours of sunlight. Number 13, put the Earth model in the winter solstice position. It's going to be way over here, on the other side. So now the other side of Earth gets darkness. Okay, and once again, Greenland, the dot is right there. And right now at this moment it is in the dark. And as I turn it, it never comes out onto the daylight side of things. It is constantly in the dark because that axis is always in the dark side over here on the back. So number 13, it gets 0 hours of sunlight in one rotation during the winter time. So they have constant night during the winter, December, January time. Okay, and then you can do, let's see here, question number 20. I guess I'm just going to tell you the answer. A country on the equator has about 12 hours of sunlight and 12 hours of night all year round. It doesn't change very much at all. There'll be a small change, but not very significant. Please enter all of those responses into Schoology.